Okay. Welcome to the winter webinar series. We've made it to February, and we have two speakers today. Dr. Macarena Farcuh from the University of Maryland, who does a lot of similar work to what I do in Maine, and Kristen Demaree, who works on a real farm in New York. And both of them have experience with using reflective row covers. So that's today's topic: use, efficacy, and cost of reflective ground cover in the orchard. So I'm done with my part. It's time to introduce Macarena Farcuh. And are you ready, Macarena?
Okay, well, good afternoon, everyone. My name is Macarena Farcuh, as Renee said. I'm an assistant professor and extension specialist working at the University of Maryland in College Park. I mainly, my research and extension is related to fruit crops, a lot of work done with apples and peaches. And today we are going to be talking about reflective ground covers and our experience from the Mid-Atlantic region. We have been working in the lab with reflective ground covers, I would say, for around 3 years now. We have been doing different projects, and so today I'm going to touch on one specific one, but if you are interested, I can also kind of tell you more a little bit of what other things we have been doing. So to start with, this will be the overview of the presentation. We are going to start by talking a little bit about the importance of color and what are the pigments that are involved in the development of color. Then we are going to talk about some of the factors that affect apple red skin coloration, and then we will jump into some of the strategies for improving the red coloration, specifically the ones related with light management and the use of the ground covers. And then I'll just share with you one of the research projects that we have carried out in the lab and finalize with the main take-home messages from what we have found. So let's start in general with the importance of color. We all know that red coloration in apples and in many fruits is highly associated with sales because it is appealing to consumers' eyes, and also, of course, from an economic perspective, the grade the apple is classified in is also going to be higher if it has at least a 50% or 60% of red skin coloration. But besides that, it's also very important from a nutritional perspective because the darker fruit, the darker color in fruits is generally associated to an increased nutritional value and antioxidant properties. Okay. Now, considering the color aspect, since I started this job, it has been a huge challenge for our growers in the Mid-Atlantic because of the poor or marginal development of skin red coloration, which is really not meeting this 50 or 60% red color that the industry is requiring, or which you need to attain in order to get these higher economic profits. So, very general, a current solution that is being placed out there is trying to delay the harvest of the fruit until this red coloration is achieved or this requirement is met. But the problem of this is that we can have an increase in pre-harvest fruit drop, as well as we can be negatively impacting overall fruit quality, as well as the post-harvest storage capacity of the fruits if we harvest them too late in the season. So it's kind of finding this balance between, do I harvest my fruit when it's really ready to be harvested, but it doesn't have the color, or how do I do this? So very general about, because we are going to dive into red coloration, I think it's important to know which are the pigments that are involved in the development of this color. So we are going to mainly touch very briefly on three pigments: chlorophyll, carotenoids, and anthocyanins, focusing mainly on anthocyanins in this talk. But chlorophyll mainly are these pigments involved in green hues that we find in different fruits. They are generally concentrated in unripe fruits, and generally chlorophyll is going to be decreasing as the fruit is ripening. And besides, it is an important constituent of what we call the background color of the apple fruit. The background color is this more greenish, yellowish color, and then we talk about the surface color, that is this red color. So then we have carotenoids that is also involved in this background color development of fruit, and it's mainly related to the yellowish or orangish hues that we find in fruits. And then finally, we have anthocyanins, which are related to the surface color of fruits. It's mainly related with these red or even purplish hues that you see in different fruits. And specifically related to apples, the content and the composition of anthocyanins are the ones that are going to determine the intensity and quality of the apple red skin coloration. So what we want is just to increase this level of anthocyanin production. Besides, anthocyanins are also related with this nutritional value of fruits, and it provides a lot of antioxidant benefits. And it is important to mention that anthocyanin production is developmentally regulated. We can have a little bit of synthesis of anthocyanin already at the fruitlet stage, but mainly it is going to be highly synthesized during fruit ripening. And another important thing to mention is that anthocyanin production is highly dependent on the sugar contents of the fruits, because the molecule of anthocyanin is composed by it includes a sugar molecule, it includes sugars for its formation. So sugars are also a very important aspect to consider here. So in this presentation, again, we are mainly going to be talking about red color, so anthocyanin is the pigment we are interested in. Then we also have that there are many factors that are really affecting anthocyanin production and apple red skin coloration. So I just want to bring to your attention this resource, just for you to know that it's out there. It is a newsletter article that we wrote some years ago with a colleague in Penn State, Jim Shoup, and a student in my lab. So it's really, it's called Apple Red Skin Coloration, a grower's checklist, and we really cover in detail all related to apple red skin coloration, which are the factors that affect it, which are the strategies that you can use to improve it, etc., etc. So if you're interested, that's a resource that is out there for you to read through, and there you also have the link, and I can also pass on the link later on. But just for letting you know. Now, there's many different factors again that influence this red skin coloration or anthocyanin contents, starting by the genetic background, which specific cultivar we are working with, and also even which strain. We know that there's newly developed strains that also achieve higher red skin coloration than older ones. Also, the rootstock is a very important factor affecting red skin coloration. The nutritional status of the orchard, of the tree, of the fruit, the canopy architecture, crop load, fruit maturity stage. As we said, anthocyanins are going to be developmentally regulated. So really anthocyanin is going to be accumulating in the later stages of development when the fruit is ripening. So if we altered using plant growth regulators or anything, the maturity stages of the fruit, we might also have alterations in red skin coloration. And finally, we also have, of course, environmental factors, which are going to be playing a huge role in the development of red skin coloration. And these are mainly the ones that I'm going to focus more in this presentation. Specifically, the two main environmental factors that are playing a crucial role in red color development are temperature as well as light. So with respect to temperature, the ideal conditions out there, if we lived in an ideal world, would be to have bright, clear days with temperatures around 77 degrees Fahrenheit and very cool nights, at least hopefully 3 to 4 weeks before the anticipated harvest dates. If we had this situation, the trees would not be stressed, we would have a high photosynthesis rate going on during the day, and there would be a decreased respiration rate during the night. So what would happen is that the sugars that are produced via photosynthesis during the day would not be totally broken down during the night. And as I mentioned earlier, this is important because the anthocyanin molecule for its biosynthesis, it needs sugars to be present. So this is a very important aspect to consider. Now, The problem is that anthocyanin biosynthesis is going to be suppressed or is going to be reduced when we have very hot days, more than 90 degrees Fahrenheit, as well as or coupled with these warm nights, which is becoming more and more common in the mid-Atlantic area. And this is really affecting all apple cultivars, but especially these early cultivars, where, such as Honeycrisp, for example, where we do not have really this temperature differential. So that's with respect to temperature. And then with respect to light, light is also a very important aspect in development of red skin coloration, because light intensity and quality, the specific wavelength that is really heating the surface of the fruit, are key because the synthesis of anthocyanin is light inducible. All the enzymes that are participating in the synthesis of anthocyanin are really light inducible. If there's no light, it's going to be very difficult for these enzymes to really be able to act. And then in terms of specific light wavelengths, we have that the ultraviolet wavelength, the one that is intrinsic to the sunlight, is known to induce anthocyanin biosynthesis. So here in this picture, I'm just showing you, it's nothing big to say, but I'm just showing you where ultraviolet wavelength is located with respect to the visible light, and just highlighting that ultraviolet wavelength is generally a shorter and higher energy than the visible light, that is the one that we see and that allows us to see all the colors. Okay. So with that background said, let's talk a little bit about the use of reflective ground covers and what is the principle of using these tools. Generally, reflective ground covers are going to be, as its name says, is going to be reflecting the light, and hopefully this ultraviolet wavelength from the sunlight, that it will reflect it back to the canopy. As you can see in this picture to your right, you can see it's the sunlight, and then the light is going to just reflect back into the canopy, especially, I would say, the lower third of the canopy. And hopefully this ultraviolet wave. If we do not have the reflective ground covers, what is going to happen is that the light would just be absorbed by the ground or by the soil surface and never reflect or bounce back to the tree. Generally, the reflective ground covers are going to be deployed 3 to 4 weeks before anticipated harvest. If we are targeting the increase of red skin coloration, that would be the recommendation. And there's many types of ground covers. We have what we call the reflective fabrics as well as the reflective films. Reflective fabrics, we can talk about Extende or Proline, which are the ones that I'm showing in the pictures there. These are these white cloth. They are more expensive. It's a higher investment, but they are reusable and you can use it up to 7 years if they are really adequately managed. And then you have the reflective films, such as the mylar. These are the metallic films. They are going to be less expensive, but these ones are just non-reusable. So it's just one season, and then you just have to replace them. Okay. So with all this background, now let's go into the one of the research projects we have been working on related with the use of ground covers. And here the objective of this specific work was to characterize the effect of Extende reflective ground cover on enhancing fruit skin red blush and canopy light distribution of commercially important apple cultivars which are grown in the mid-Atlantic. So what we did here is we worked with trees and fruits from Honeycrisp in M9 and Evercrisp, which is a cross between Fuji and Honeycrisp. And these ones that were grown in B9. And all of these trees were located in Pennsylvania. We worked with 2 different treatments that you can see there in the pictures. Treatment 1 is with the deployment of Extende. It was deployed around 4 weeks before the anticipated commercial harvest. And then treatment 2 is our control. There's no Extende. But besides the Extende, the management of the orchard, of the rows, of the trees is exactly the same. For each treatment, we had 4 replications, and each replication consisted on 23 blocks. And what we did is we harvested the fruit and evaluated them at 3 different dates during the ripening process. So in the case of Honeycrisp, we did it at those 3 dates in September, September 3, 10, and 17. And Evercrisp, it's a later ripening variety, so we did it October 15, 22, and 28. What did we evaluate? We did a lot of fruit quality evaluations. One thing I have to mention before I forget is that for each one of the cultivars and treatments, the fruits were always harvested from the lower third of the canopy at these different dates during ripening. We had done previous work where we had also evaluated fruit, the effect of Extended on fruit harvested from the lower third and also fruit harvested from the upper third of the canopy. And in the case of the upper third, we did not see any benefit of using Extended, so we decided to just concentrate this work now in the lower canopy because the light is being reflected back and mainly enhancing or helping out the fruit that is located in the lower part. So in terms of fruit quality evaluations, we evaluated a lot of things, but because of time and time constraints, I'm just going to focus on what is related with color evaluations. So what we did is we used an objective measurement of color, which using the instrument called the colorimeter, which you can see here in the first picture to your left. This instrument really is going to allow us to give us a value, what we call the hue angle, which is really a value that we can associate with the level of redness of the fruit. Or the level of green or yellowish hues of the fruit. We measured this in the blushed and the unblushed side of the apples. Then we also did just eyeballing skin red blush percentage that we saw in the fruit, and we also used a DA meter to measure the chlorophyll content of the fruit. The difference of absorbance meter or DA meter. Okay. We also wanted to know if there was an effect of Extended in pre-harvest fruit drop. So for that, we did, for each cultivar and treatment, we assessed fruit drop percentage weekly for a period of 4 to 6 weeks during the ripening process. And we also wanted to know what was going on with the canopy light distribution. So for each cultivar and treatment, we measured light interception and the ground cover reflectance using a Lycor meter in order to determine the photosynthetically active radiation wavelength, which is more related with the visible light, but also, and most importantly, was what was happening with the ultraviolet wavelength. That is the one that we know that is really critical for the development of red color. Again, our primary focus was on the lower third of the canopy, and the measurements were performed proximal to solar noon in cloud-free days on the north and south sides of 4 trees per replication in each cultivar and treatment. So now let's look into some of the results that we obtained. Let me walk you through the graphs first, but it's going to be exactly the same layout for Honeycrisp, and then I'm going to show you what we got for Evercrisp. And so what you are seeing here is the 4 parameters related with color that we measured for Honeycrisp fruits. The skin hue angle in the blushed side, then the hue angle in the unblushed side, the blush percentage, and the chlorophyll content. In the x-axis, you have the 3 harvest dates that I told you we did throughout ripening on the tree. And in the y-axis, you just have the units that we measured with. And the important thing is that the black bars stand for the fruit where the Extended was deployed, and the white bars are the control bars where there was no Extended. So what we observed, if we start looking at what happened with our hue angle in the blushed side of the fruit, we can observe that throughout ripening, in all cases, the hue angle tended to decrease. And that's what we expect, because when the values are lower, it means that there is a change of color towards a more red coloration. That is what we are looking for. And then we could be able to see that the hue angle was always, in every single ripening time, was lower in fruit where Extended was deployed with respect to control. That means that this fruit was able to achieve a more darker red skin coloration. Then we did the same, but now looking at the unblushed side of the apple. We wanted to see if there was any effect with the use of these ground covers on the background color, on this change of greenish to a more yellowish or even cream color. And what we were able to observe is that, again, the hue angle values were lower in fruit which had the deployment of extende with respect to control fruit. If the values are lower, it means that there is a change from a greenish color to a more yellowish coloration. So it's showing us that the fruit is ripening. So we observed that fruit with extended deployment had also a darker yellow skin coloration in the unblushed side or in the background color. Then we also measured skin blush percentage just by eyeballing what percentage of the fruit was covered with red. And here what I'm doing is highlighting with this dashed line the 50% mark, which is kind of what we were trying to aim to reach this 50% of red skin coloration. That is really what the market is requiring and that what is economically more profitable. So what we were able to see is that extended deployment was able to increase skin blush percentage at all three evaluated dates with respect to the control fruit. As you can see that the three black bars are substantially higher than the white ones. And the marketable blush, meaning more than 50%, was achieved around 2 weeks before in Honeycrisp fruits, which were where extended was deployed with respect to the control. The control also achieved it, but it was around the last stage of evaluation that we were doing. Okay. And then finally, we also looked at what was going on in terms of, this is also related with the background color, with the chlorophyll content. Again, we would expect that there is a decrease in chlorophyll content, this change from a greenish to a more yellowish coloration. And for this, we used another instrument, the difference of absorbance meter, or the DA meter. And here, all you need to understand is that if we have a lower value of IID, it means that there is a lower chlorophyll content, meaning that there is a more yellowish coloration. And Honeycrisp fruit with the deployment of extended presented significantly lower IID values at all the evaluated dates as compared to the control fruit. So in Honeycrisp, at least, we were seeing an advantage of using extended in terms of red skin coloration as well as effects on background color. And here I just put some pictures for you to see. You can see on the top the three harvest dates that we had. And you have the first row is without extended, the second row is with extended. So just for you to visually see that these differences that we were observing. And then we did the same for Evercrisp. So this is exactly the same layout of the results, but in this case for the cultivar Evercrisp. What we were able to see in terms of skin hue angle in the blushed side is that the hue angle was again lower with extended diploid fruit with respect to control throughout all the three harvest dates, indicating that we achieved a darker red skin coloration in the fruits where extended was deployed. Then when we looked at what was going on with the unblushed side with respect to the hue angle, we observed in this case that, again, as we observed in Honeycrisp, the hue angle was lower in extended diploid fruit with respect to control fruit, indicative of a greater change from a greener to a more yellowish coloration. Then the skin blush percentage, we were able to see that also extended deployment was able to increase the skin blush percentage at all three evaluated dates with respect to control fruit. And finally, with respect to the changes in chlorophyll content, this was a bit different of what we saw in Honeycrisp, because in this case, we did not see any difference in chlorophyll changes with or without extended. And here again, it's just pictures for you to see with and without extended, the difference in color And there you can just have a view of one of the treatments we had deployed, where we had deployed the Extended. Then I also mentioned that we wanted to see what was going on with pre-harvest fruit drop, if Extended had or not an effect on increasing or decreasing pre-harvest fruit drop. So this is the results I'm showing you here. In the graph of the left, you have the results for Honeycrisp. In the right, it's for Evercrisp. And here you can see in the x-axis the different dates where we evaluated weekly. We were counting how many fruits had dropped with respect to our initial count. And we have the black bars are for fruit where Extended was deployed, and white bars, again, is just control fruits. So what we could observe in general in both cultivars is that really there was no significant difference in fruit drop percentage throughout ripening between Extended and non-Extended deployed treatments in any of the cultivars. So we could conclude that Extended seems to not be increasing the fruit drop percentage in fruits. And then the last thing we evaluated was with respect to the canopy light distribution. We really wanted to see if there was an effect on this reflection of the light back to the canopy. So for that, what we did is we evaluated two different wavelengths, the PAR, or photosynthetically active radiation, as well as the ultraviolet radiation, which we know that is very important. Both are critical for red color development, but ultraviolet is even more. We evaluated the values that the results I'm showing you here corresponds to reflectance, so how much is reflected from the ground cover back. And what you can see here is in both graphs we have both cultivars, so you can see in the left Honeycrisp and then in the right Evercrisp, and always the black bar is with Extended and the white bar is control or no Extended. So what we can see is the light ground cover reflectance for both cultivars in the photosynthetically active radiation or PAR wavelength, as well as in the ultraviolet radiation bandwidth, was always higher in the lower third of the canopy for Extended treatments. And as I said, ultraviolet and PAR bandwidths are vital for or critical for red skin color development. So we effectively were seeing that there is an increase in the reflectance of these bandwidths with the use of Extended. So with that, we will just go into the take-home messages. We observed that the deployment of the reflective ground cover Extended in fruit from the lower third of the canopy of Honeycrisp and Evercrisp cultivars was able to enhance apple fruit skin blush percentage, also showed a decrease of the hue value angle of the blushed and unblushed skin sides. That means that on the blushed side, it means that we observed a darker red skin coloration, and on the unblushed side, it means that we saw this change of coloration from a greenish to a more yellowish background color. We also observed a decrease in chlorophyll skin content of the unblushed side by lowering the index of absorbance difference. We observed this mainly in Honeycrisp. We did not see that so much in Evercrisp. Besides color differences, we also were able to see that Extended deployment seems to have no effect on increasing fruit drop. And we also observed that Extended deployment improves canopy light distribution by significantly increasing ground cover reflectance in the PAR as well as in the UV bandwidth. So the use of Extended does improve fruit skin, red blush, and canopy light distribution of commercially important apple cultivars grown in the Mid-Atlantic conditions. So with that, I want to finalize by just acknowledging the collaborators in this work and of course the funding agencies that helped us carry out this project. I want to thank you for your attention, and I'm happy to take any questions.
I have a quick question for you before I go into the chat and read other people's questions.
Okay.
So you said you measured light during solar noon. Have you considered measuring it at different times of the day, and east versus west or north versus south?
No, we have not considered. We could consider that in a future work. We have mainly been collaborating with Jim Shoup doing these
Oh, yeah.
measurements because he is mainly more the expert in that area. So yeah, what we have done is that I didn't show here, but we did in other work, is we have measured in sunny days as well as in cloudy days, at always at solar noon, and we have also seen like these remarkable differences, with extended always reflecting more um, UV radiation versus control. But that
Have
is
you
a good
worked?
point.
Oh, thank you. Have you worked with trees of different sizes, like semi-dwarf versus dwarf, or short versus tall, and measured the percentage increase based on tree size?
So what we have done is mainly work with commercial orchards and cultivars that are important for the industry based on what the grower associations really recommend me to work with. So we have been decided this like that. Um, I don't know if the different tree sizes, we could have done different, there could be different conducting systems of the different cultivars we have worked with and different rootstocks, but I would say the main, when we have really compared differences, is when we did this work, this previous work, where we just focused on what was happening with fruit in the upper third of the canopy versus the lower third. And it was really conclusive that in the upper third, we kind of didn't find much difference or much effect of the extended, which makes sense because there's a lot of light irradiating there. But what we observed is that the use of extended helped us kind of uniform the ripening of the tree, because now the lower third could kind of catch up with what was happening up there in the upper third. So that's what we have done
Interesting.
so far.
Thank you. Now I'm going to go to the chat questions. And from the first question is, does reflective ground cover increase fruit surface temperature and risk of sun browning or necrosis?
Yeah, that's a great question. We have not observed, first of all, I have to say we have not measured fruit surface temperature, but this is something that we are planning to do because it has come up now more and more. We have never observed so far sunburn damage to in any of the fruits that we have measured, but that depends where you are located, because I guess if you think of more of the West US, maybe in the Northwest Pacific, the risk of sunburn might be a lot more than here. We generally do not see a lot of sunburn, and in our experiments, we have not seen it, but doesn't mean that it will not happen, or if the weather patterns continue changing, it's something to consider. But yeah, the temperature changes is something that we want to focus on measuring this next season for sure. And there is some work that shows that there might be differences too.
Okay, next question. Is there a minimum duration of time required to achieve coloring benefits? This person was thinking about how growers could move ground cover around the orchard from early to late ripening varieties.
A minimum duration of time to achieve coloring benefits.
It's hard to answer everything with one experiment.
Yes. No, I'm just trying to think of all that we have done, but we have, again, we have mainly been doing what is recommended with deploying these 3 or 4 weeks before the anticipated harvest, and we have seen the results then. I cannot say if that would be the minimum because I have not tried what happens, but I guess that if the recommendation is 3 or 4 weeks, it's because it has been tried that with lower amount it just doesn't work. Considering, remember that we need to induce these enzymes that are going to produce or synthesize the anthocyanin, so this pathways needs to be activated. Um, I would say that 3 weeks is something that would be the minimum from my experience to get these results, but we have not tried less than that.
We have a lot of questions, and I'm not sure we have time to go over them all before the next speaker, but I'll do two more,
Okay.
and then I'll save them until the end. Do you have increased vole damage as a result of the ground covers?
No, we have not seen that.
Okay. Are there any notable impacts to the orchard floor?
That is also a very good question. That I have seen, no, but again, we have not done formal research on this, but talking to the growers or the people that use this and that know their orchards better than me, there seems to not be a notable impact on the floor. There could be more retention of humidity, things like this that could be helping also the temperature of the soil and things like that, but these are things that we are thinking now on starting to research more in depth now that we saw that there were these effects. Now we are trying to go a little bit further on what's going on with the whole like orchard atmosphere. So that's what I have to say for now.
Well, thank you very much. Will you be sticking around to the end?
Yes, for sure.
Our next speaker is Kristen Demaree, and she's going to talk about some of the economic aspects of reflective ground covers.
So on our farm, I'm Kristen Demaree. I'm the farm manager of Demaree Fruit Farm in Williamson, New York. We're about a quarter mile south of Lake Ontario. We've been using Extende now for the past 7 years. My parents had gone an IFTA trip to New Zealand where they saw the Extende there, saw the benefits of it. And I think that year bought our first couple acres of Extende. And over the course of the past 7 years, we've continued to purchase more and more acres. We are a 200-acre commercial fresh fruit farm. I think 95% of all of our plantings now are high density, tall spindle plantings. Our average spacing is about 3 by 12. So like I said previously, we have 42 acres now of material that we will use across 125 acres across the season. So we'll reuse that material and move it from an early variety to a mid-season variety to a late season variety. We typically will apply the material 2 to 3 weeks before harvest for our early and mid-season varieties. For our late season varieties, we typically try and do 2 or 3 to 4 weeks before harvest, just because you don't have quite the amount of sunlight and sun hours during the day. But we have actually moved the material as little as 4 days before we harvest, and we've seen a difference in the color in just 4 days. So when we do put the material out, we'll put it out, like I said, a couple weeks before. If we have to do any sort of spraying, or when we have to go in and do a first pick or a second pick, we just unhook one side of material and then move it to the side, go down that row with a sprayer or with a harvest crew. And then once they finish that row, they'll go back through and hook everything back up. So the Extende will be able to go and remain on the field for both the second and the third picks. So we were able to fabricated our own trailer. We haven't been able to find any sort of commercially available trailer or system. I think every grower we've talked to that has Extende kind of makes their own system. So we were able to fabricate our trailer based on some of the measurements from a grower out in Washington. So the cost of that trailer for us at the time was about $2,350. We do have 2 trailers now, and just to help with efficiency of putting out the large quantity of material that we do have. We also found that during harvest, we have really small windows to try and get as much done as we can. So by having the 2 trailers, we're able to do twice as much work in that time frame. So to roll out the material, usually attach it behind either an ATV, an RTV, or tractor, and then pull it out. And then people will come behind and attach the Extende with the bungee cord and the hooks at each pole of the trellis, so that way the material is taut. And then for rolling it up, the trailer has a hydraulic motor that will help draw the material in. We have found that if you have any material that is wet, the friction in trying to roll it back up is like almost impossible. So we do have to wait until any sort of morning dew or rain that got on the material is dry. We also found that about 500 to 600 feet of material is about as far as length you want to put out. Again, it's just the amount of friction involved. So in really long rows, sometimes we'll put like 2 shorter pieces of material out. So that way it is just easier for the machine to draw up. So this is just a picture that we had of comparing Extende to no Extende in Honeycrisp. This is just a regular strain, regular Honeycrisp. So obviously the picture on the left is no Extende and the picture on the right is with Extende. That would have been put out about 2 to 3 weeks before. I think the picture says it all. There's a significant difference in the amount of redness in the fruit with the Extende. And we'll put our Extende on every single variety that has a 50% or higher red standard. Unless that variety is already a naturally occurring red apple like Crimson Crisp, everything else we put Extende on. So we got a quote in September of last year in 2023 for what the cost of 1 acre of Extende would be. So this is the information from that quote. So we do the Extende E-Series, which is the 7-year life. I think there's different series you can buy and that will change the cost of the material, but this is kind of the most durable, long-lasting. And that'll be about $2,100, a little over $2,100 per acre. Then with between the rubber cord and then the wire claws, that's an additional a little less than $300. The corner ties that are required to, at the end of the rows, tie the material taut are about a little less than $50. And then for the 10-foot PVC pipe, which you need in order to be able to roll up the material on something and use your trailer, is about $330. We did originally, when we first had a couple acres of Extende, we made wood pallets to be able to store the Extende on when we weren't using it during harvest. What we found was that we couldn't store too much material on the pallets. The pallets broke down after a couple of years and we weren't able to stack the pallet. So it took up a lot of space in the barn. So this past year, we fabricated some steel racks pallets that we could put like I think 2 to 3 times more rolls on a pallet. And it allowed us to stack the pallets. So now we take up significantly less space in the store, in the barn. So 42 acres is a lot of Extende. And this quote does include freight prices as well. On our farm, we do have 2 teams of Extende, and each team will go with a trailer. And then that team will consist of 7 people. And then we'll also have a forklift driver who will divide his time between the 2 teams. One team will average about 2 hours per acre, both to install and to remove the material. Typically, that installation or that kind of 2-hour window will be about 30 minutes it will take to install the material, and then an hour and a half to remove the material. It's definitely much more time consuming to roll up the material than to put it out. So we've been tracking our labor costs for the past 4 seasons now, where we're able to see exactly how much like labor was involved in the Extende. So in 2020, it cost us $351 an acre to both install and remove the material. But this past season, by making a lot of changes in our efficiency, we have been able to lower our labor costs per acre to a little less than $240 an acre. So we were able to lower it by $111 an acre over the past 4 years. The biggest difference in us being able to do that was particularly in 2022. And that's where we completely changed out our workers on who was assigned to the Extende teams. We initially, our slowest picking team was our Extende teams because we felt that those teams would be, we were losing the least by having them go and do extend day, but we also found that most likely your slowest picking team will be your slowest extend day team. So definitely be smart about who you choose to be on those teams and putting out the material. So when thinking about this presentation and how to like evaluate the economics, we actually had a block this past season that was the perfect example. So this past season, we had 2 gala blocks, and one gala, they're both 15-year-old trees on a 4 by 12-foot planting on a NIC 29 rootstock. There was a 2-acre block and then a 1-acre block that was just a couple hundred feet away from the 2-acre block. We did not put any extend day on either block initially because we just ran out of material with our other varieties. There are Brookfield Gala strains, both of them too. So after we did the first pick on September 13th, we realized that the fruit that was left on the tree was quite close to the trunk. And because of the size of the canopy, we didn't think that if we left the fruit for another like week to 10 days, that we would be able to get very much fresh fruit left just because of the location of the fruit. So that same day in the afternoon, we installed the extend day in the 2-acre gala block, but not the 1-acre gala block because the rows are very short. And it just wouldn't have been kind of like feasible at the time. Plus, we only had so much material. So the extend day was on for 8 days, and that's when we performed the second pick where we cleared the trees. So looking at comparing the returns that we received from the fruit picked from those 2 gala blocks and only evaluating that second pick fruit to compare the extend day versus the no extend day. From that 2-acre gala block with the extend day, we were able to get almost double the amount of fresh fruit bushels per acre compared to juice. But it was kind of the opposite for the 1-acre block. We almost had double the amount of juice than we had for the fresh. So we actually averaged our true returns of fresh or for fresh bushels, which was 1036, and then multiplied that by the actual fruit bushels per acre yields for both blocks, as well as our $3 a bushel for fruit. And what we found was that the gross income increase by utilizing the extend day was $2,296 per acre by putting the extend day on after the first pick. So again, this is just on the second pick fruit, and with 8 days of having the extend day on. So now looking at what our net returns would be for that gala block. For the material cost, again, was a little over $3,300. But because you have a 7-year lifespan, you could have, if you just use that material once a season, that would be a 7 uses total. And that would be about $471 in material costs. However, if you move that material during the season, then that would be 14 uses, and that would cost you $235. Because we use it 3 times during the season, which would be 21 uses, it's only going to be $157 an acre. With the labor costs, we were actually pulled the data of what it took us to both install and remove the material from that specific 2-acre block. And it was $263.02 per acre for the labor costs. So if you compare the gross or subtract those 2 costs together, or excuse me, if you add those 2 costs together and then subtract it from that gross income increase of a little under $2,300, we found that the net income per acre by adding that extend day was $1,867.40. So I didn't include the cost of the trailer in that number just because it would be so nominal. I think it would be like $1 or $2. So just keep that in mind. So for some considerations, like I said before, you want to definitely make smart decisions on who assists with moving your materials. You definitely want to choose motivated individuals that are willing to work as a team. We had a lot of difficulties with people not really communicating well, or they weren't they were kind of strolling down the orchard rows and not moving at a normal or even quick pace. And that really adds up quickly when you're looking at and you're tracking the labor involved. So because of that, and by choosing and switching out people on the teams, we were able to lower our labor costs by just about $112 an acre for over the past 4 years. Secondly, I didn't put this one on there, but because we use our material multiple times during the season, what we did find is instead of ordering 1 acre's worth of material, but also bungees and claws, we'll order 1 acre worth of material, but then we'll order 3 acres worth of bungee and claws. So that way we can leave the bungee and claws in all of those orchards throughout the year, and we only have to move the material. The bungee and claws, having to unhook those from, collect them, unhook them, hook them back up, that does add a significant amount of labor involved. So I would highly recommend just leaving them, buying enough to leave it across every orchard you plan on using it in, because that will significantly decrease labor costs. Lastly, you potentially might need more workers during harvest. In 2023, for us, for the whole season, it took 14 people, a total of 13.3 days of work to move the extende, both install and remove, across those 125 acres. We did not have 2 weeks worth of free time during harvest to be able to do that. So we had to bring in about 3 to 4 extra people to be able to pick and also accommodate that extra movement time with the extende. Potentially that could lead to, you may need more workers, as not everybody has to experience this, but in New York, we do have an overtime threshold now, and it is lowering. So we potentially might need to bring in more people to accommodate that, and potentially more housing as well. So that's it, if anybody has any questions.
What about varieties like Gala that have different maturation dates on the same tree?
So for us, like I said, we'll leave the extende in the field the entire time that we'll pick a variety. So whether it's 1 pick or 4 picks, we just move the material to the side and then put it back immediately once we finish that row. So that way the fruit that's left on the tree will continue to benefit from the extende.
I think this question was for Macarena, and were you doing your research on the tall spindle system?
Yeah, many orchards we work with were tall spindle. Yes.
Any disadvantage from putting the reflective ground cover in place earlier than 3 weeks before harvest? Either one of you, if you know the answer.
From
Kristin, you
our
can go.
experience on the farm, no. But if you have a windstorm and you have it out for a long period of time, it can act as a sail. And so you have to be, this is pretty much for any extende, but I think the longer you have it out, the longer the risk potentially, that you do have to kind of keep an eye on things, because it will eventually lift up and potentially unhook. And
Okay.
But I can also add that this is not research we have done, but there's also other researchers that are looking at deploying it for the whole season, and you can also have some advantages in flowering, in all these other areas that could be of importance. But it also has some, as Kristen says, and also the limitations. I don't know if you want to do sprayers or stuff, you always have to be taking it out and putting it back, etc., etc. So.
It's a thank you to Kristen for the information. Do you completely avoid driving over the ground cloth? Kristen.
Ideally, yes. I think, like I said, this is our 7th year using the material, and I think it will last more than 7 years from our experience, but that's because we don't drive in the material unless we absolutely have to. It does definitely, I think in Washington, they'll drive on it more than we do, but they have sand. When we drive on it, because the grass is underneath, it definitely like starts to pull the fabric, and it'll start to rip the fabric where the hooks are on further down the lane. So we don't drive on it at all, if possible.
Thank you everyone for coming today, and thank you to our guest speakers. This was a fascinating topic and has motivated me to consider doing some research on this.